Button accepted.
How fancy was that? I really like that. All right. So the on-site conferences are back. I really love that, especially because we can have some interaction with the audience. So before I actually jump straight into the presentation, if I can ask you if you could raise your hand if you or the company that you work for are using A/B testing in practice, on real production. If you do, please raise your hand. All right, just a few people. And that's great. Why? I have to confess something. I do quite a lot of public speaking, and my favorite topics are not about the bleeding edge technology, but about things that everyone is aware of, everyone has heard about, but people do not use them in practice. Because they think that these things can be used only by unicorns, unicorns, the greatest, the grandest of the world, which in fact is not true. So that's why I speak about topics like A/B testing, or chaos engineering, or, for instance, full stack observability solutions. All right, so without further ado, my name is Sebastian Gebski. I'm a principal solution architect. I work for AWS. You probably have heard about us. I cooperate with startups across the whole EMEA, so Europe, Africa, Middle East. And today, I would like to show you in practice how you can very easily start your journey, start your adventure with A/B testing. So that's the short plan. Let's talk about the problem we are trying to solve. Let's talk about why this problem is viable, why A/B testing, what is A/B testing, and why A/B testing may be a solution to that problem. Let's see some short demo. There will be some React development done by myself, so just be warned that this can be either scary or funny. And then, of course, let's summarize it a little bit. OK, so this talk is mainly aimed for the product developers, so people who actually work for companies who have some sort of a product and develop it long term. So let's start with an assumption. You have an MVP. You have something which is already developed. It's deployed, and actually there is probably someone using it in the wild, in the internet. So you have the initial version, but you would like to evolve it. This initial version was created based on some sort of a vision. We wanted to create another Uber for gardeners, or Airbnb for kindergarten, whatever. So you already have it, but you would like to make it better. You are not really sure, do the users like this application? Or maybe this next idea that you're going to implement, will this be a success or a fad? But the problem is that if you just develop this idea and spend some months on it and then deploy it, you will probably know after the fact, which is quite late. Because the money is already invested. You've already spent the money on developing this new feature, but the problem is that the feature is not that great, and people do not really like it. So it's a problem. The product development is not easy, because you typically know that whether you've done well or not after you've done it, which is far too late. Of course, you can ask your users. You can ask them about their opinion. You can tell them, we are going to work on a feature X. What do you think? And the problem is that, of course, if you have already 1 million users, you cannot ask all of them. Of course, you could create probably some sort of an online form, but how many people do actually answer and fills those online forms? So that's probably not the best idea either. Of course, you can publish your email address and ask people, please send me an email with your feedback, and that doesn't really work, because usually all the mail you get are from the frustrated people who really had a bad day. So we need something which is based on far more objective data. We need something that is not based on a bias of a particular person. And we need it. We need it to drive our product development, to make sure that our product gets better and better and better. So how to do that? Well, there are 3 pillars that you should keep on your mind if you want to have a really data-driven product development. So the first idea here is to make it based on the comparative analysis. So for instance, just let people vote with their clicks. Share 2 versions in the same time to similar cohorts of people who have similar preferences, and just somehow observe the results. So what are the differences in the behavior for those 2 versions? Of course, you need to measure those results. So you need to have some sort of KPIs to understand which version is better, which version will be more beneficial long term. And as I said, you should not really ask people for some informal feedback, because of course this anecdotal feedback can be very useful as well. You need some more objective feedback, you need raw data, and this can be derived only from the behavioral analysis. So for instance, if you have an e-commerce site, just analyze the behavior of your users. So how much time did they spend on the search page? And what does it mean if they spend there a lot of time? What does it mean if they spend them very little of time? So if you follow those 3 principles, you probably can build some data-driven loop that can help you build a better product. So there's a screenshot of some e-commerce site. Some of you may even recognize it. And yeah, the idea of what could have been changed here to follow those 3 principles, well, basically everything. Because this is the version which is deployed right now. And you can clearly see some sections here. And those sections have some purposes. For instance, as you can see here, actually I was logged in. There's my name here in the very top row. So this is probably personalized for myself. And this site probably already knows I'm male, it knows my age, my preferences, and so on. So that's why you have this huge banner in the top, gifts for dad at great prices. This is probably very contextual. Maybe because that was a Father's Day, maybe because some of those articles which are in some sort of a resale or promotion are under this category. However, what if we make this section smaller? Would it somehow impact how people behave? Maybe they will click more in different sections. Maybe actually they will completely omit this one. But we will not know until we try. At the bottom, you have 4 sections. What if we make them a little bit more narrow to put here the 5th one? Would it somehow change the behavior of the users or not? Having a wider choice, does it really help them to make a good decision about buying something or not really? We don't know until we try it. Of course, we can change here many more things. We can take the menu from the top and we can put it to the left. Those items are based on some sort of recommendation algorithm. We can change this algorithm. We can try version 2. This algorithm is probably driven by some variables, by some input parameters. We can probably shuffle a little bit those parameters. So we can change pretty much anything here, but we don't know whether it will be beneficial or not. That's the question we would like to have answered. Will this be beneficial or not? All right, this technique, so changing things, changing small things, and learning the outcome of this single change, it will not work in all the cases, in all the scenarios. There are some scenarios where it will work and some where it will not. Of course, you need to have something to compare. So you cannot test completely new functionality this way. You need the old version first. So there's the old version, there's a modified version, so you have something to compare. Well, of course, it makes sense for the small changes. Because if you just recreate the user interface completely, there are so many atomic changes that you don't know the impact of those atomic changes. You just know the impact of the whole new user interface, which probably took a lot of time to develop. So that's not how it should work. Of course, you need some traffic. So you need some, because if you want to make reasoning based on statistics, you need the traffic to base these statistics upon. So if you're just starting, and if this MVP has just 10 registered users, it's probably too early to try A/B testing. And of course, you need to understand your user base. So if you want to do some comparison, then you need two populations which would behave in a very similar way. They have a very similar expectations regarding your site and so on. And in the end, probably the most important thing, you need to somehow evaluate those options. You need some sort of KPIs that you compare to determine which option is better for your company and for the end user. So how is it typically implemented? You know, the switch over between those two options. Well, you're probably familiar with the term feature toggle or feature flag. So basically what it is just a way to adjust the behavior of the application in runtime without a change in the code. So yes, it's just a conditional statement, it's just the if statement. But the reality is that it's a little bit more complex. Because a functional change can be, scattered across many places in your code. The part of the change may be in UI, the part may be in the service, the part may be even in the database. So it means that you need to have several if clauses across your whole code base to implement a single feature toggle. The implementation here, diagram here is very, very simple. So there's an application, a React web application created in Amplify, and it calls the API via API gateway, and the API is basically Lambda functions. And you have two groups of Lambda functions here. The first one, the top one, the products, is actually your features. So it probably retrieves a list of the products. And the bottom one is the piece of API for the feature flags. So that's the one that you make a request to learn the value of the flag in your front-end application. And in this case, feature flags were implemented using a service named AWS App Config. And of course, your Lambda, the products Lambda, so the business feature Lambda can call the app config as well to determine the value of the flag. So the idea of the feature flag is that you learn the value of the variable. For instance, which version of the feature should I use? But this value doesn't have to be the same for all the users. That's the key thing. So imagine that you have 1,000 users, and you want to test two versions of the application. So maybe 50% of them should get version 1, and 50% of them should get version 2. So they may not even know it, but they get a different application, the different look and feel, and you are able to measure the impact in their versions of the application. All right. So there's some problems with this approach. That probably, if you already use feature toggles in your applications, that you realize that having all those ifs and maintaining those code versions in parallel on a single branch, it may be an issue because you are polluting your code. After you delete your feature flag, you need to remember about removing the feature flag. So that's one issue. Another issue is that you need to poll the service that gives you back the value of the feature flag in runtime. It cannot be cached, because in some cases you want to turn the feature flag off in case of some trouble, for instance. So you have another heavy dependency, runtime dependency. And this service that gives you back the value of the feature flag, it has to be super highly available. It has to be super resilient and super fast, just to make sure it doesn't affect the user experience of your application. And of course, there's also an issue with the testing complexity. Because if you are running in the same time 10, 20, 30, or even more feature flags in parallel in your application, it means that the end user can get any combination, or pretty much any combination of the values of those feature flags. And this can be very tricky. I can give you a very short anecdote here, that we are running an initiative called CTO Morning Coffee, which is basically some meetings on Twitter Spaces, and we are just using Twitter application, which I guess everyone knows Twitter is super simple. So we've started using the new feature, which is called Twitter Spaces, for the first time with 2 of my colleagues. And we're trying to set up all the basic things. And we figured out that we cannot do this. Because apparently, some things work only for some of us and not for the other one. We've compared Twitter application on our mobiles. We all had iPhones, the recent models. And the surprising fact was that all of us had different version of the Twitter client. All of them were up to date, but all of them looked different. Because there are so many feature flags running on Twitter that the actual appearance of Twitter differed for us all, which was very surprising, keeping in mind how simple the application is that. OK, so what are the basic use cases for feature toggles? Well, the first one, and probably the most famous one, is the continuous delivery. So if you practice trunk-based development, if you have just one long-running branch, if you do not keep short-lived branches, if you don't follow Git flow, GitHub flow, or whatever, then you somehow need a way to disable your piece of code that is not active here yet. You have to control what is being turned on and what is not. So that's when the feature flags are super useful. Another case is, of course, the canary releases. So we have some risky functionality that you would like to deploy, and the issue is that it's not possible for some reason, maybe because of the dependencies, it's not possible to perform full load testing or full stress testing. So what you do is you perform the canary release. For instance, you enable this functionality only for 1% of your users. And then you monitor all the metrics, you run all the telemetry just to find out whether there's an issue or not. And of course, you increase the population of the users with the feature enabled. Graceful degradation, maybe some premium features, and of course, A/B testing. Because feature toggles isn't enough to do A/B testing, but this is the foundation of A/B testing. So what is A/B testing? I had this definition because I think it's a little bit too much. But the basic idea of A/B testing is just having some sort of evolutionary change and comparing those 2 versions, the version without the change and the version with the change, using some objective KPIs, business KPIs that you have defined, and determining which version is more beneficial based on those KPIs, making it a next default version, and evolving from now on in the same loop. So starting with another change, adding another change, finding out which one is more beneficial, and so on, so on, so on. This definition that you can see here is a little bit wider. Why so? Because it adds randomization. So it's more like mutating A/B testing. So it's about looking for some non-obvious solutions. So for random changes that could make the difference. For instance, let's make the background pink. Maybe it will work for someone. So something that no one has thought about, but maybe actually this will have a beneficial result. So the idea of this loop that I've just mentioned is very important, that you need to start with some sort of hypothesis. So what do we want to change? Because we expect some outcome. So do we want to change the layout? Do we want to change something about the algorithm? Do we want to change some threshold, acceptation threshold, or something like this? So what do we want to change? And when we have this is typically based on some sort of research. Then we need to know what options do we want to try, because we cannot try all the options. So we need to try a few options. Then we need those KPIs that we want to measure. We need the code that will measure that. And of course, then we run the experiment, summarize the learnings, and so on. And that's how it goes. And this is probably the most creative slide for this whole presentation, because creating those hypotheses is the trickiest part. Why so? For instance, let's start with the first one, tweaking parameters of the recommendation engine. So what you see here in the black font is actually the hypothesis, and what you see in this purplish is what I would like to measure for this hypothesis. So we're tweaking parameters of a recommendation engine, and what do we want to measure? How many clicks happened on the recommended items? Because my assumption is that if more people click those items, it means that the recommendation actually match their preferences. So my recommendation algorithm is good. Yeah. What about the point number 2? Which layout encourages users to browse more? Because we want people to browse our marketplace, for instance. And here, what I would like to measure is the session time. Does it make sense? Not really. It doesn't have to. Why so? Because the fact that someone spends more time on our marketplace doesn't have to be beneficial. Because maybe, yes, they like the products because they see the products, they are interested to them, but maybe this new layout is just confusing. And they are used to our site, so they are here because they like it. But the problem is that they are struggling to find what they really like. So I just wanted to illustrate how tricky it is to find a good hypothesis, because you should not really change things randomly on your website, right? On your website or on your other kind of application. All right, so as I've mentioned, the general idea of using feature toggles is quite simple, because this is just some if statements. So you need to learn the value of the feature flag, then drag it to your application, and then use if statements to serve 2 different versions or 3 different versions of your application. So it sounds super simple. So why do we speak about some sort of a managed service, which is called CloudWatch, evidently, in this case? Well, the thing is, it's quite a philosophical story, I would say. So if you want to know, if you want to know the whole story, just pick me after this presentation. But in general, do you know where the best cloud services come from? One of the sources of the best cloud services is what I call reverse dog feeding. What is reverse dog feeding? It's when you create an internal product just for yourself because there was a need, and at some point it's so super useful for you internally, no one else knows about it. It's so super useful for you that you decide to turn it into an asset. Why don't we share it with the wide world? Why don't we give it to everyone else? Why don't we package it as a black box and maybe make some money out of it? So that's what happened with Evidently. Amazon.com is a huge marketplace, and they use feature toggles and A/B testing all the time. And they serve incredible amount of traffic. I think that last May, Jeff Barr has published some numbers about AWS IAM, so the authentication service. So the amount of traffic which is served there is 400 million requests per second. So CloudWatch is, I'm not sure which one is more popular, so which one gets more requests. I'm not really sure, because CloudWatch is about the telemetry, so you can imagine there are some requests going there as well. So if you have this infrastructure so highly available, so robust, that you can rely upon, you don't really want to implement it on your own, especially if it's something critical for your application, because the actual looks will be rendered based on the outcome from the service. So there's a service for you, which is called CloudWatch, evidently, and you can use it. How it works? It's super simple. So we have a user. The user is using the application. And then what the application does, regardless of whether it's a server-side, of a front-end side, client-side application, it does the feature evaluation. What is a feature evaluation? It asks about a particular feature. For instance, how many columns do I want on my screen? And it asks about the variation. And each user, by user, I mean some sort of identity. It doesn't have to be a physical user. Maybe it's a session. Maybe it's a segment, whatever. So it asks for the variation for this particular user. So each user gets her own variation of this feature. And what is this variation? It's decided based on some traffic split. For instance, you can have a feature with 2 variants, and you can decide 50-50. 50% gets version 1, and 50% gets version 2. And then it's just drawing the random number and assigning the value based on this random call. So we start with the evaluation. And once we have this evaluation done, what happens next is we are sending events. And those events, the custom events, they are used to calculate those KPIs that will be used later to actually evaluate the experiment. And the evaluation of the experiment can happen in the service because there are some dashboards. You will see that in a moment. Or you can use this data. You can push it to CloudWatch logs or even to S3, and you can do the analysis on your own. So it's up to you. So basically, it's that simple with a little twist that if you don't want to create your own events, you can also use so-called RUM events, real user monitoring events, which are very basic and they are used for some client-side performance insights. So if you are super lazy, you can do this. OK, before I show you how it works in practice, you need to understand 4 terms: project, feature, launch, and experiment, which are super simple. Project is just the bag for everything else. So for launches, experiments, and so on, so on. So on the level of the project, you define what's the name and where do you want the data. Do you want them just in evidently, or do you want them to push into, for instance, into S3? And that's pretty much all. What's a feature? Well, feature is a feature toggle or a feature flag, whatever you want to call it. So here on the screen, you see a feature flag of the type long, which has 3 variations. I haven't actually put any values yet. You will see that a little bit later. And what is also interesting, you can override the value of the feature. So for instance, if you have some internal testers, you can just assign the value by hand. You don't have to have it completely random. So that's an option for if you want it under control, at least for some users. What is a launch? Launch is the launch of the feature. So initially, the feature has only the default value. So for instance, if we start from the baseline where our screen had 4 columns, and we build the feature which will give more variations, so for instance, 5, 6, 7 columns, before we make an actual launch, there will be always only 4, or always only the default value. So here is the launch, and for the particular feature, which is just the Boolean, disabled or enabled, we are deciding that 50% of the user will get disabled and 50% will get enabled. And the final concept is the experiment. And what is the experiment? The experiment is a launch with some metrics associated. Because you want to track those metrics to make the decision which version, which variant of the feature flag is more beneficial. You will see this, that in a moment in practice. OK, cool. So I will show you an application. This is the architecture. It's very simple. I call it 2.5 layer or 2.5 tier architecture. So basically, you have containers on ECS. You have a relational database. And you have a load balancer over the top. That's pretty much it. And of course, there's also a client application. This one is SPA created in React, in JavaScript. So there are 2 interesting points that you should see here on this screen, point A and B. So A is just the browser, because there will be some logic based on the feature flag in the browser. And B is the logic in the container, because there will be some logic that makes some changes in the container, so on the server side. The order is very important. If you want to deploy this in practice, if you want to start with that, you need to start with the feature, because you need this default value first. Then you need to instrument your application. Then you need to pepper your application with some code to actually use those feature flags. And then you need to create the launch. Before you create the launch, nothing will change from the end user perspective, because always it will be the default value which will be served. And of course, the final step is this experimentation and drawing up the conclusions out of the metric data. So about the instrumentation. This is actually from the client side, so it's all JavaScript. There are just 3 short pieces of code just to illustrate you how simple is this. So here's the one which creates the client. It's a part of SDK. and it's added to all the SDKs that are available for AWS. So this one is JavaScript one, but if you're using Java, it's already present there. If you are using Kotlin, actually Kotlin SDK is not generally available here yet, so I'm not sure whether it's already added. However, there are two parts of this screenshot, the commented one and the uncommented one. And what is the difference between them? Well, the top one is for the server side. So if you already have some access key, secret access key, if you, for instance, have them in the environment variables, that's how you initialize the client. It's that simple. If you want it on the client side, for instance, in the browser, of course, you should not put any kind of secret access key there, but then you use something which is called cognito pool. So, for instance, you can map a logged-in user, even if you use some third-party authentication on some temporary credentials. So it's very simple. And literally, this is that much code to create that client. When it comes to the feature evaluation, it's just that. So you create a command where you specify which features would you like to evaluate, some entity ID, so how do you recognize that this is a unique user, because you need to assign the value of the feature flag exclusively for each user, and then you just send this command on the server side using the client that we have just created. And then, actually, this command is the batch evaluate command, so you can ask about many features. So then you need to find the answer in the response. All right, so these are my React skills. As you have probably already recognized, this is a Netflix clone. There are 3 sections here. The top section is just, let's say, login, logout, information about the user. And the important information here is that I will do the feature evaluation each time the user logs in. And my user, or my entity, is not really a user, but the session. So it means that if I log twice using the same user, for instance, in this case, Flynn, I will get different values of those feature flags. Because I wanted, let's say, more dynamics, and I wanted them to change more frequently. This section below is the recommendations. There are some shows on my platform, and you can watch them, and here are the ones which are recommended for you. I'm not super happy with this section. I'm not sure whether it works, but it's here. And of course, below, you have all the other movies on the platform. So we have Avatar, Breaking Bad, and so on, so on, so on. And so this is not based on the recommendations, but it's presented in columns. And I'm not sure how many columns is optimal here. Maybe 4, like here, is OK, but maybe I should add more or less. We don't know that. OK, so let's see how it works in practice. And I just want to show you the experience of someone who works with those feature flags from the level of someone who triggers them and stops them. Yeah, so that's how this application works in practice. Does those recommendations. You can watch the show, sort of. So for now, nothing is. This application is without any enabled feature flag. So let's switch over to the Evidently console. OK, we have a project. The project is called Octank. And this project already has some features. The 2 of them are important, show columns and recommendations. So the one in the middle and the one at the bottom. So show recommendations is about whether to show this gray section or not. And columns is about how many columns we would like to render. So let's create a launch, the launch for the recommendation section. There's a feature which is Boolean, enabled or disabled, false or true, show this section or not. And we're creating the launch, so let's decide that we split it 50-50. So for 50% of the user, this will be enabled, and for 50%, it will be disabled. And we create a launch. The code is already instrumented. Because the feature was created, the code is instrumented. So right now, we need to wait a second or something, and this will trigger off automatically. So it means that without any kind of redeployment, yes, it's on, we can move back to the application, log out and log in, and as you can see, the section is missing. Of course, I can log in again, and for some of the sessions, it will be visible. Because each time I log in, the feature is evaluated again. OK, so that's nothing really impressive. But let's try to run another launch, because all the features are completely independent. So why don't we create the launch for another feature? So the second feature will be about the number of columns, the recommendation columns. So as you can see, this is actually a numeric feature. So there are values 1, 2, 3, 4, and 5. And obviously, they correspond to the number of the columns which will be rendered. And again, I split the traffic equally. So my default, which was served until now, it was 100% right now. It will be 20% as all the other versions. Let's try it. Again, it will take a second or something. And these are completely independent. So it means that they are like randomized in complete separation. And again, it should work without any other action, because the code is already instrumented. So I switch over to the application, log in, log out. OK, it's 5. Again, it's 5. But now it's 3. And so on. So each time those values are being determined dynamically based on the evaluation. And what I can do right now is I can adjust those values, this traffic, in real time. Because, of course, I can mark the launch as complete, but I can also, for instance, decide that there will be 90% for the version number 5. That's how you can run, basically, the Canary launch. If this is your purpose, if you don't care about A/B testing, if you just want to create the Canary launch. So right now, in majority of cases, it will be 5. Sometimes it's less, but in general, typically, it's 5. All right. So, OK, so it's feature flags. It's very simple. You don't have to change a lot of code, but it's not A/B testing yet. To actually have real A/B testing, you need to report some metrics. And that's the piece of code that you need to use to do that. You create some payload. In payload, there are 2 sections. Details, which is metrics, and metadata, which is the section that identifies your unique identity. So user, segment, company, whatever you want to as your identity. Then you send this command. Then you send this payload. And in this case, it's the custom event. It's not an RUM event. Of course, you also send some client-side timestamp. And that's pretty much all you do. So let's try to show how it works in practice. And then also, let's see how the recommendation engine works in practice. To do that, I will show another demo. But this one will be without UI. This will be completely console-based. So let's turn the problem a little bit upside down. Because in general, if you have few versions, you don't know which one is the best. You don't know the effectiveness of those versions. But in this experiment, we will know. How come? Imagine there's a shooter. The shooter shoots at the target. And the shot is just drawing the random number from 1 to 100. And if there is one coefficient called accuracy of the shooter. Let's imagine it's 40%. So if the number is 1 to 40, it means that the shot was a hit. If it's above 40%, it means that it was a miss. So let's imagine that we start with a shooter who has 40% accuracy. And we turn this accuracy into a feature. And we create some variants, and each of those variants will have different accuracy. We will run this experiment, so those several shooters, and then in the end, we will evaluate which shooter is the best one. So we will have a default with 40%, but we will also have 20, 60, and 80. So intuitively, the shooter with the 80% of accuracy should be the best. Definitely. Let's see how it works, and let's see whether it really is like that. Great. So we already have the project, which is called Octang. It's the same project. And the feature is already defined. It's called threshold. So as you can see in the definition, the configuration of this feature, the feature is the percentage. So 20, 40, 60, or 80. The default value is 40, so exactly like I told you a moment ago. And this feature, this is actually already launched. Let's switch over. And I have a script, very basic script that I'm running, and this will emulate the shooters. So what happens here in this script, it starts with the feature evaluation. So I'm asking about the feature, which is the accuracy. And in the next section, calculation of the success, I just draw a random number, round range 100. And if it's below the evaluated value, it's hit. It means the result is 1. If it's not, it's 0. It means the result is a miss. Then I send this payload, just like I showed in the screenshot a little bit ago. And all this procedure is repeated in the never-ending loop. So I just run this single session, then have a very short sleep, and run it again, endlessly. The delay here is 0.1 second. What you can see in the console here, I've just interrupted it, is that right now the feature is not launched yet. So you can see 40, 40, 40, 40, 40, 40. It's all the time, it's evaluated, the accuracy is evaluated to 40%. So nothing really interesting happens yet. And the JSON, which is below the 40, so below the accuracy, is the actual event that is being sent to evidently. So there's a success based on this accuracy which is being sent, and the device is just the identity of the session, because each shooter has a different identity. It has a different unique identifier. All right. So we have some sort of data generator that we could use. But of course, to have it make any sense, we need to run launch or run an experiment. So let's run an experiment. Create experiment. We need to call it somehow. We'll need to pick the feature, so the feature with the name threshold. Yeah, you recognize the values. And of course, we need to decide about traffic. So how will the distribution of the traffic in our experiment look alike? It creates, and we need to define the metric, because the metric will be used in the automatic recommendation. And actually, we need to find the path in the JSON that we sent as a payload of the message. So I need to copy and paste it. So for entity ID, it's metadata device. And for the actual value of the metric, it's detailed success. We can name the unit, which is just a text, so don't bother with that. And that's pretty much it. We can create the experiment. But the experiment is created, but it's not running yet, because we need to define the time frame. The experiment is supposed to take some time and finish. So we need to wait a second until it's created. And we'll be starting the, exactly. The tutorial even tells us that, sorry, but you still need to start it. So what we're doing here is we pick the experiment and we start it. And right now it will ask us about the time frame. And I was recording this in April, and it suggested me that 1 week of time is actually makes sense. But I've shortened it to 10 minutes. I didn't want to really wait 1 week. OK, so let's make it 10 minutes. OK, so the experiment is actually live, as you can see, but we're not generating data, so we need to switch back to the console. OK, so what's the difference? Right now, each row has a different probability, different accuracy, 20, 40, 60, because the experiment is running. So the experiment is associated with the launch. All right, so we are generating data. Perfect. So right now, we need to wait 10 minutes, which, of course, we want to do. That's the moment where I cheat. You see 0% of the progress here. And right now, in a moment, this will magically, skip to 98%. And I cheated a little bit. I didn't want you to wait here for 10 minutes. I also changed another thing. So I removed the output console, and I've shortened the delay, just to make sure that I generate even more data. So the data in the experiment is more meaningful. All right, so let's see. Let me refresh. Perfect. It should be, yes, it's done. So the analysis is completed. the experiment is completed, we are ready to actually learn what has happened. So we interrupt the script, and we can click the results. What do we see here? It's 100% completed, uninterrupted. Brilliant. OK, so this first diagram, it's quite interesting, but it's also quite obvious. Because it just shows the number, the events count for all the variations of the feature. So as the distribution was 25% each, you should expect pretty much the same count for all of them. So it's not really revealing, but at least it confirms what we've set up. What is far more interesting is the table below. Let's scroll down to that. All right, great. So what do we see here? The event count is what you see at the graph above. What is interesting is the total value. So how many, it's just the sum of all the successes, all the successful hits that have happened. And the average is, of course, the total value, so how many hits per all the event count. So as you can see, for the shooter or for the variant with the 80% accuracy, we actually have 79%. So we've confirmed the obvious, yes. For 40%, we have 40%. For 60, we have 72. For 20, we have 19%, and so on. So we've started, as I said, we've started the hypothesis with already known result, and we've just confirmed that. We've just confirmed how it works. This example is quite trivial, but you can easily evaluate how all the other columns work. For instance, there's an improvement. And our metric was the number of hits. We wanted more, the more hits, the better. So in this case, we had more hits for the same, approximately the same number of all the events. We have almost 100% more hits. So it means that it's almost 100% better with a high statistical significance. So it means that all those entries in green, they are more beneficial than the original 40%. And actually, in the last column on the right, which you will see in a moment, there will be a clear recommendation. Based on all those versions that we are running, which one of them the algorithm would recommend. Yeah, the best performing was, of course, the shooter with 80% accuracy. Because the higher accuracy, the better. So this example is quite trivial. But imagine that you create such experiments for the features which are not that obvious. So maybe you change the layout, maybe you change the algorithm, maybe you tweak some options. All right, brilliant. I will not show you the final data, the final demo, because it's very simple. And what it does is actually shows you how the data is exported into S3. So you can use all kinds of tools that you like to actually process the data. For instance, you can use Athena to query the data. You can use EMR or whatever if you have a lot of data. You can merge the data with some other inputs and so on. So what are my suggestions, or what are my, let's say, personal lessons learned or drawbacks from this? Well, in general, the first thing is that if one of your goals is to have a proper product development practice, so if your company is product-driven, if you are selling the product, offering some sort of SaaS service or something, the shorter your development cycle, the better. And if you really want to shorten the development cycle and you don't want to waste time on regression testing and coordination, integration, and so on, then probably continuous delivery is necessary. And if you want to implement continuous delivery, you need to embrace the feature toggles. Anyway, even if you don't want A/B testing. Don't be afraid to experiment, especially if you have a very stable platform that you can rely upon. In general, if all your product development is based on some person's vision, you know everyone can make mistakes. So it's not possible that this person will be right all the time. And of course, the most tricky part of advice is that before you actually run any experiment, you really need to know what you want to measure. Because if you don't measure anything and you're just experimenting for the sake of experimentation, it doesn't mean that you're not gaining any knowledge. and without gaining any real knowledge, to be honest, it's quite pointless. There are some resources and links that I would like to share. And I think that the most interesting of those is the link number 3, which is a new open source initiative, which is called Open Feature. If you know, Open Telemetry is some sort of an equivalent of Open Telemetry, but for feature toggles. So the idea is to have an open standard, so all the solutions can follow the same standard, and they can be very interchangeable. And the idea is to, for instance, to provide a way to standardize deployment of the application, for instance, on Kubernetes, in a way that you can have a standardized listener for instance, feature evaluation as a sidecar that can be deployed pretty much with any application that is running on Kubernetes. So the project is at the very early stage at this point, and we don't know whether it will succeed or not. It's completely open source. It's not associated with any corporation or anything like this, but it's definitely something that may be very interesting in future. And also, a very interesting point is the last one, so number 7, which is the library of infrastructure as code constructs for CDK, which you can use, because I was showing you the web console, right? But pros don't use the web console really. So if you really want to deploy it in a civilized way, so feel free to take a look at the construct in CDK, so we can do this in an automatic way. OK, thank you very much. If you have any questions, if you would like to learn more about use cases, about the practical application of this, or about anything else that I've mentioned today, please feel free to catch me somewhere in the corridors. I will be there for the rest of the day. If you want to contact after the conference, here's some contact information that you can use. Thank you very much. Have a nice rest of the conference.